I'm going to start by being really controversial. I don't like the word accident. In fact, I think it's the wrong word. Every time we have an accident, it's a big surprise. So what is an accident? Well, my view is it's a systems failure. Something has actually failed. It's so easy just to blame the person and say they got it wrong. But who did get it wrong? Where are the problems lying behind that? So let's think about what is a system. And many people don't actually understand what a system actually is. But in fact, it's a whole series of interconnected parts with a single goal. Simple example, your own body, a connection of a whole lot of systems. An aeroplane, a car, a factory. Whole lot of interconnected things with a single goal. Now you can have redundancy in that. So for example, lots of people might not have an appendix that's been taken out, or unfortunate people maybe lose a hand or a leg, but they can keep going. But once your heart stops, that's fundamental. If your brain stops, that's fundamental. So it is with something like an aeroplane or a car. There are key components. Once they fail, then that's really serious. So, okay, I've talked about systems. So let's look at a system. What I've particularly used here is an oil production platform, very common in Scotland and many other parts of the world. A harbour, it's an airport, it's a factory, it's a hotel, it's a hospital, it's all of these things with the single objective of getting oil out of the ground or out from underneath the sea. So let's look at that in the diagram I've got here. So we've got the diagram of the oil rig, and look at this. These are the boundaries, all the sorts of boundaries, and systems have boundaries, but many boundaries because they're interconnected. So if we look at the first set here, we've got operators, owners, shareholders, systems, subsystems, workers, contractors, and safety systems. So the whole operation is made up of subsets and subsystems in themselves. And then we go wider than that. And you'll see in here other things: technology, organisation, finance, costs, legal requirements, and even the political, economic influences. So things will be happening outside that. It's not straightforward. Now, some parts of these might not work. If the canteen doesn't work on the oil rig, it's going to make some guys pretty annoyed, but nevertheless, it's not central to the actual operation of the thing on a day-to-day basis. So it's these various bits and pieces which interact, good weather, bad weather, and such like. You can see all of these in this diagram. But behind all of this are the human elements. Everything requires humans behind it. So when something does go wrong, it's not just the person with their hands on the controls. It's got to be the person who designed it, who created it, and all of these people are involved. Human elements run through absolutely everything. Apart from the elements of nature, people are involved at every point. Even in nature, you could say, well, what is the interaction with that? We talk a lot about hazard and risk. Well, what's a hazard? Well, it's something like the sea or the weather or something like that, and we only have a risk when we interact with it. So if we go to sea, it's interacting with the sea that's where the risk is. So let's look at what causes an accident. Well, it really is, again, looking at a diagram here, the fundamental thing in any accident is change. Something's changed. Something's different from before. Whether you've crashed your car or a plane's crashed, even if you're ill, something has changed. And that change means there's a loss of control of the system. And that leads on to the consequences, which are the system's failure, the accident, the incident, whatever you want to call it. But what causes change? A whole variety of things. Look at some of them here. Possibly the problem's not understood. We see that buildings fall down or planes don't work. We're currently seeing a lot of problems with Boeing in America. They haven't fully understood some of the problems. Then we've got unforeseen design and construction issues. One of the big things we're seeing currently, there is a reinforced concrete, aerated reinforced concrete being used in schools. Its lifespan isn't what they originally expected. So it's an unforeseen thing. They didn't anticipate these things going to go wrong. And then, of course, poor or no plan. You've got to have a plan. And if you haven't planned that well or thought it through, including the risk assessment, then it's likely to go wrong. We would call these latent failures. These are the hidden failures. Every incident or accident is a surprise. We don't expect it to happen, and it comes up and it bites us. So these are the latent failures, the hidden failures that we've got within that. In order for these things to go wrong, then you've got barriers and controls which have been defeated. It might be something like a permit to work, or it might be a physical barrier. Somebody's decided to climb over a gate or go through a gate that they shouldn't do. In the companies we work with, which are all respectable, good, powerful, big companies, they have sophisticated systems for safety. And it's only by breaking barriers and controls, or if they're missing, that the accident occurs. So I've put barriers and controls in here, as you can see. This red box all around the outside are the human elements. As I said a few minutes ago, we cannot have an accident without human elements. Everything is designed, your house, your car, your lifestyle, there's a design behind it. So the human element is fundamental to everything that we do. I've put in another term in here, incubation period. In a sense, it's the accident waiting to happen. I've said a few times, an accident is a big surprise for people. Well, it's cooking away in the background. It's happening maybe in your company, my company just now. We don't know what's going on. There's something happening there. It's cooking away. That's the incubation period. And that's when we do investigations, that's what we're looking at. We're looking at what's happened in this incubation period. Another term which I introduced many years ago is one called organisational rust. Now let's look at the idea. It's a bit like real rust, which of course is oxidization of metal. In an organisation, we've got standards and controls represented here by the green line, and that's the ideal situation, provided that in itself is correct. Sometimes it's not correct. But we drift away from that, and you can see that this is us drifting into a zone of danger, which you'll see in the right-hand side of my diagram here. And I've also put in the barriers and controls which have been defeated. Things can go wrong once you drift away from that standard. But again, we're into the incubation period. That period there is when things are actually going wrong. And even slight changes cause incidents to occur. So coming back to look at all of this, what we've got with any sort of incident, things go wrong. And why did they go wrong? Look at that and establish what were the human factors that caused that, because humans are behind that. And that's what's behind the whole TopSet program, is looking at every single element to establish what has gone wrong. And from that, we come up with a plan to resolve what's actually happened and to prevent it happening in the future.